In this video lecture, we're going to start talking about concurrency in Java, and specifically how to invoke threads in Java and to interrupt threads in Java. In separate lectures, we'll be talking about synchronization and some of the higher level protocols Java has for dealing with threads. A good source of information or notes for this lecture can be found in the Java concurrency tutorial. So if you go to my notes and you say concurrency in Java, it'll take you to the concurrency tutorial, and that's a good place to get information. First, we need a couple definitions. We're going to call a process a self-contained execution environment, which you would typically think of as a program. And a thread is going to be a lightweight process that exists within a process and shares the process's resource with other threads. So it shares the process's address space, it shares the process's local variables, and the different threads can modify the process's local variables, and depending on what you do, these changes should be visible to other threads and to the process itself. The Java memory model is something called a shared memory model, which means that all the threads are sharing the same memory. And if one of them modifies it, the other should be able to see it as well. Java has two threads mechanisms, a low-level one that we'll be discussing in this lecture, and a high-level one that uses something called thread executors and tasks that we'll be discussing in a separate lecture. In this lecture, we're going to be talking about the two different ways you can invoke a thread. The first is through the Runnable interface, and the second is going to be through the thread class. The first way, through the Runnable interface, means that your class has to implement an interface called Runnable. It has a single method called run, returning a void, and in run, you put whatever code you want the thread to execute. So here we simply want it to print hello from a thread and then exit. When run terminates, the thread terminates. You can see at the bottom that we have created a new instance of our Runnable. Now, in order to actually cause it to start executing as a thread, we have to create an instance of a thread, passing our instance of a Runnable as an argument, and that alone is not enough to start the thread running. It simply creates a thread, and in order to get it running, we have to call start. This simply adds the thread to a queue of executable threads. It does not necessarily start executing the thread immediately. It could be that main would continue executing, and at a later point, your thread would start executing. So you can't be sure that the thread's going to start executing right away. The second way to create a thread is to subclass the thread class. And here we're extending thread, and again, we override the run method. So we're simply printing, again, hello from a thread. And now we simply create an instance of a hello thread, and again, we have to call the start method in order for it to start running. Either way is a fine way to create a thread. Runnable has the advantage that you can use or you can subclass another object. So you'll notice by implementing Runnable, we're now able to subclass some other object. Whereas with thread, you can see we're not going to be able to subclass any other object. However, thread provides a slightly simpler interface because we simply create the thread directly by creating an instance of the class, whereas with the Runnable, we had to create an instance of the class and then feed it to an instance of a thread. Now, when you're running a thread, you sometimes may want to pace it. For example, if you're doing an animation, if you're doing a clock, if you're doing a simulation, you may want to be able to suspend the execution for a specified period of time. The way that we do that is with the sleep command, and you'll notice that it's a static method of thread. not a method that you call on the object itself. When you call thread.sleep, the thread class checks to see which thread is currently running and puts it to sleep for the specified number of milliseconds. When this happens, we give up the processor, the thread gives up the processor, and some other thread is then allowed to run. And again, we do this because we're looking to pace the execution in some way. Now, just a quick note here. If you are doing some kind of graphical user interface, you typically are not going to use threads to implement your animations. There's something called a swing worker class that you would typically use for doing animations. And the swing worker class has its own thread mechanism that we may or may not talk about in a separate video lecture. With threads, we also need the capability to handle interrupts. We may want the main procedure that forked us to interrupt us in some way, and we have to have a way of handling interrupts. The interrupt method may be invoked on any thread to notify it of an interrupt, and then the thread can handle the interrupt in one of two ways. First of all, it can catch an interrupted exception. And this only happens when you have called a method like sleep that actually is able to throw interrupted exceptions. So this is something that if I was in main, let's say I had gone to sleep for 10 milliseconds, and then main calls and says, I'm interrupted. Sleep would now throw an interrupted exception, and it could be caught, and I can do whatever I want. Typically, when I'm interrupted, I'm going to immediately exit, perhaps doing some cleanup work, because the most common reason for being interrupted is your services are no longer required. The second way to test to see if you've been interrupted is by calling the static method interrupted in the thread class. This will check an interrupted status flag for this thread, and if that flag is set, it returns true, otherwise it returns false. It also clears the interrupt flag and resets it to false. You typically call thread.interrupted when you're in long executing procedures that don't make calls to methods that call or that throw interrupted exception, and you typically want to periodically monitor the status flag of interrupt because you don't want to hog the CPU. So here's two examples, one using interrupted exception, one using the interrupted method. In this first example, we are printing out some information from an array. And you can see the array is called important info, and it simply is a string array that has a series of messages. You can see that we're iterating through that array and that we print a message and then we sleep for 4,000 milliseconds. So we're printing a message every 4 seconds. And we are, during the sleep process, we put it inside a try, so if someone interrupts us, we can catch it, and in this case, we're not going to print any more messages. We simply return immediately. Remember, that's the most common way to handle an exception, is to simply return, or if we need to clean up some things, clean them up and then return. The second example is one where we're simply doing a lot of processing. Here we're assuming that we are iterating through an array of inputs. We call some procedure called heavy crunch that takes a bunch of time to process each input. After we've processed each input, we check to see if some other thread or process has tried to interrupt us. If so, we return, and we again assume in this case that our services are no longer required. Now, in some other situations, we may simply give up the CPU and let some other thread continue to execute. So to provide an example of how sleep actually operates, we're going to look at a simple thread that prints out hello from a thread. And in main, we're also printing hello world, and we're simply indicating it comes from main. Up in the thread, we're indicating it comes from the thread. In each case, we're going to print the message 10 times. So in this first invocation of main, we're not having any sleeps. We're going to create our thread, ask it to start, and then we're going to print 10 hello worlds. Our thread's also going to print 10 thread messages. So let's compile that and run it. And you can see that main first got through with its 10 hello worlds, and then the thread was activated and it did its 10 hello worlds. Now let's try putting a sleep into main so that it will have to yield the processor and let the thread run. So we will call sleep, and remember, it's not a method call on the object, it's a static method, and we're only going to yield for 10 milliseconds, but that will be enough for us to give up the processor and let the thread start running. And we will catch an interrupted exception. And in this case, because I don't anticipate anything happening, I want to run to completion, so if I catch an interrupted exception, I'm simply going to ignore it. I want to run to completion. So let's compile that and run it. And you can see main now got in one of its hello worlds, but then it was it slept, and that allowed the thread to get in and to print its 10 hello worlds, at which point the thread exited, and ultimately main, when its sleep period ended, regained the CPU and printed out 9 hello worlds. Now let's also add a sleep to the thread, and that means both of them are trying to sleep for 10 milliseconds. Again, let's compile it. And now you can see we get interleaved execution. And you'll notice too that it's not perfectly interleaved. So initially main has the floor and it prints hello world. It then sleeps for 10 milliseconds, allowing the thread to get the processor, and it prints hello from a thread. Now the thread sleeps for 10 milliseconds, but you see that it actually gets awakened first and prints out its second hello from a thread message. Then main, hot on its heels, gets awakened and prints hello world, and from then on you can see that it's a pure alternation. But you can't assume that the clock is A, exact, and B, you can't assume an order in which things will get awakened. In this case, you'll notice the thread actually somehow got awakened before main got reawakened, at least after the first sleep for the thread. Now we also sometimes want to have a way for one thread to wait for another thread to complete. We call this relationship where one method has to, or one thread has to happen or do something before another, a happens before relationship. And we can ensure that one thread completes its actions before we continue by using a join. And that will cause us to suspend our execution until whichever thread we ask to join with completes. So in this case, when we call t.join, we will suspend our execution and wait for thread T to finish its execution. When T finishes execution, it will notify the Java virtual machine in some way, and our thread will be placed on a ready queue, ready to be executed. Notice we may not execute immediately, as some other thread may get the processor before we do. So let's look at a detailed example now. And what we're going to be doing is printing out a series of messages. And the main is going to invoke the thread. The main is going to be waiting. Every second is going to print a message indicating it's waiting. And every 4 seconds, the thread is going to print a message, one of mares eat oats, does eat oats, little lambs eat ivy, or a kid will eat ivy too. So let's first just execute the program so you can see what is happening. So you can see that main is printing still waiting. Now thread 0 just printed mares eat oats. Main's waiting. After 4 seconds, thread 0 prints another message. Again, 4 waiting messages. Every 4 seconds, thread 0 prints out a message. So thread 0 is simply iterating through an array and printing the message every 4 seconds. Now, notice at the end main said finally. We can also interrupt the thread early. So I'm going to now run it for 10 seconds. And after 10 seconds, the main's going to kill off the thread. It's going to interrupt the thread. So we're 8 seconds in now, and now we're 10 seconds in, and you'll notice that after 10 seconds right here, main says it's tired of waiting. It issues an interrupt. Thread 0 protests, I wasn't done, but it still yields, and main now says finally. Let's take a look at the code now, and we're going to start with the thread that actually prints the messages. It's called message loop, and it's implementing the Runnable class. And you can see that it is creating an array of 4 messages that it's going to print. And it is going to print those messages inside a try block that is going to catch an interrupted exception. And you can see that if it catches the interrupted exception, it's going to print the protest I wasn't done. But you'll also see that it returns at this point because the for loop that's iterating through the array is inside the try block. Therefore, when the exception is caught, the loop is exited. We catch the exception, and you can see that we exit the procedure. The for loop is simply iterating through the array, and before printing a message, it sleeps for 4 seconds, and then it prints a message. And thread message, if we take a look at it, is simply a function that takes a message and it prints out the name, or gets the name of the current thread. You can see that we can query the thread class using the current thread method to get the name of the thread, and then we simply print out the thread name and the message. Now let's take a look at the main procedure, and you can see that first of all, main is throwing an interrupted exception. So we're also going to have main sleeping for a second at a time, but if it gets interrupted, it's simply going to throw the exception up to the virtual machine and the program will exit. And if by default we're going to wait an entire hour for the message loop to print its messages. However, remember we're allowed to provide a command line argument that limits the amount of time to some number of seconds. So in that case, we reset patience to be the number of seconds times 1,000. And of course, the user has to give us a number, we throw an exception and exit. And as you see, the first thing we do is we simply print a message that we're starting the message loop thread, and we're recording the current start time so that we can exit if our patience is exceeded. Then we create the new thread and we start it. So these two statements right here, create the new thread and start it. And now we indicate that we're waiting for the message thread to finish, our next message. Now we enter the loop, and while the thread is alive, we're going to print a message that we're still waiting. Then we're going to execute a join method. And notice we have specified 1,000 milliseconds. What that says is we're only willing to wait 1,000 milliseconds before we want to be awakened and take some action. So you're allowed to put some limit on how long you're willing to wait for a join. You don't have to wait indefinitely. So the join can terminate either because the thread T finished or because we waited the full 1,000 milliseconds. Now, if we waited the full 1,000 milliseconds, then we want to check to see whether our patience has been exceeded. So we check the current system time against our start time, and if that exceeds our patience tolerance, and the thread's still alive. So if the thread finally terminated just at the last second, we don't want to print that we're tired of waiting. But if the thread is still alive and our patience is exceeded, we print the message tired of waiting, and then we interrupt the thread. And now we again wait for it, but we are assuming it's well behaved and it's going to terminate itself. And if you remember, that's exactly what happens if the thread, when it catches an interrupted exception, it says, I wasn't done, but it relinquishes, it does finish up and exit. Hence, this join should happen fairly quickly at this point. And then after the loop is over, after the thread has died one way or another, we simply print out finally. So regardless of whether we had to terminate the thread or whether the thread died a natural death, we print finally at the very end. Hopefully this video lecture has given you an idea of how to fork some threads in Java, and also how you can interrupt a thread, how you can paste a thread using the sleep command, and how you can wait for another thread to finish using the join method.